for me. Really frustrating. Okay, so today we're talking about factoring using the AC method. You guys did this in Math 1. You absolutely did this in Math 1. So the AC method is a strategy used to factor trinomials with 3 terms. That's why it's called a trinomial. It's called a trinomial. That word tri, we learned that, right? It's just a polynomial with 3 terms. So think of the AC method as a way of undoing the FOIL box. You're going to take your 3 terms and break them up into the 4 terms from your FOIL, and then you're going to factor them. So the first thing that you want to do, the steps are to look for a GCF. Remember, a GCF is the largest number that divides what? Do you guys remember? Yeah, it divides all the terms. It's the largest number that divides all the terms. What about the exponents? How do we deal with exponents on the variables? What did we say yesterday? It's the smallest power that they all share. Do you guys remember that? So for your variables, you want the smallest power that they share. So this is for your variable terms. You're going to list all the factors of A times C and then find the pair of their factors. So I actually call this a times plus chart because you do A times C and it has to add up to B. A times C has to add up to B. So I just call it a times plus chart. And I wrote down an example. I think it's easier if we have something. So for example, if I had the trinomial 6x squared plus 13x minus 5. Let's just practice this idea. We need to figure out what the product of A and C is, and it has to add up to B. Well, it says here to just list all the factors. So what is A times C? This is A. This is C. This is written in standard form. So what does A times C become? It's negative 30. So let's list factors of negative 30. So I'm just going to list all the positive factors, and then we can decide which one needs to be negative. So 1 times 30 is 30, but when I add those together, I get a 31, right? That's not going to work. Because I'm looking for a sum of 13. What are some other factors? What about 2 and 15? Okay. Let's see. If I take a positive 2 and a negative 15, what's that going to sum up to? Negative 13. So I really need to take a negative 2 and a positive 15. These two multiplied together give me the negative 30. And when they add them, I get the negative 13 that I'm looking for. Okay. So it says take those two factors and break them up to rewrite your trinomial so it has 4 terms. So 6x squared minus 2x plus 15x minus 5. So really, all I did was rewrote 13x as negative 2x plus 15x. That's all I did. Just found a different way to do that so I can group it. So we can factor by grouping. This is what our homework was last night. What is the greatest common factor between 6x squared and negative 2x? 2x. What's the greatest common factor between 15x and negative 5? 5. So when I take a 2x out of the first term, 6x squared divided by 2x is 3x. Negative 2x divided by 2x is negative 1. I took out a positive 5 from my second grouping. 15x divided by 5 is 3x. And negative 5 divided by 5 is. Do I have a repeated term? Do I have that copycat? Yes, I do. So I'm going to take that term write it first, 3x minus 1 times 2x plus 5. This is a product of two binomials. That is what that trinomial is in factored form. So we split it into 4 terms, split the middle into 4 terms, and then we just factor by grouping, and that's kind of what we did. All right, so I'm going to go down to this example down here, and I'm going to write a special note. When a equals 1, the factors that you choose are the factors you use, meaning you don't have to group it. They just are what they are. So I want to show you by this example and see if you can kind of understand what I mean by that little saying. So let's see. When I think about multiplying, A, which is 1, times C is 20. So I'm looking for factors of 20 that add up to, what's the value of B? 9. Okay, let's list some factors of 20. 1 times 20, 2 times 10. How about 4 and 5? Okay, so 1 and 20 don't add up to 9. 2 and 10 don't add up to 9, but 4 and 5 do. So these are the factors that I want. So the method up top says that you just take those two factors and you break it up, right? So we're going to write this as x squared plus 4x plus 5x plus 20. So I've taken my trinomial and broken it up into 4 terms, and I look for the GCF. What's the GCF in this first grouping? Yeah, x. What's the GCF in this second grouping? 5, right? So when I take an x out of that first grouping, x squared divided by x is x. 4x divided by x is 4. Took out a positive 5. 5x divided by x is, 5x divided by 5 is x. And 20 divided by 5 is, here's your repeated term. That comes first. And what you have left over is your second term, x plus 5. Notice that my factors, right, are exactly the factors that I chose. And that's because the value of A is 1. So when the leading coefficient is 1, whatever works in your times plus chart, those are the numbers that you're going to use. You don't have to do the grouping method. It's real quick, okay? So for example, B, we do have to use the grouping method. We do have to use the grouping method because A is not 1. A is 2. So let's see. A times C, remember this is A times C. That's 6. Has to add up to B. What is the value of B? 5. Okay. So let's see. Let's do factors of 6. 1 times 6. 2 times 3. Okay. So those are the two factors that I'm going to use. I'm going to just break up that 5x. So I'm going to write it as 2x squared plus 2x plus 3x plus 3. Notice I'm not really changing the problem. 2x plus 3x, those combine. Those are like terms. They equal 5x. I'm just trying to give myself 4 terms so I can use the grouping method. Okay, I'm trying to give myself 4 terms so I can use the grouping method. So, greatest common factor here, 2x. When I factor out a 2x, I'm left with x plus 1. What about here? Take out a 3. When I take out my positive 3, I'm left with x plus 1. So my factors are x plus 1 and 2x plus 3. How many of you remember this from Math 1? Yeah, that was like all of That was the biggest chunk of stuff that we did. Like if and you were in foundations, that was all of semester 2, pretty much. All of semester 2. Okay. All right. Let's go to the next page. So tell me about example A. What is the leading coefficient? 1. So A equals 1 here. So that means that once we set up our times plus chart, the factors that we choose are going to be the factors that we use. So I'm looking for a product of negative 63 and a sum of 2. That's what I'm looking for. So let's just think of numbers that multiply together to equal 63. Let's see. Oh, I was going to say 3 and 21, but yeah, how about 7 and 9? Which one of those needs to be negative to give me a negative 63, but a sum of positive 2? If 9 is negative, then when those add together, they'll be negative 2. Yeah, make the 7 negative, okay? Because look, negative 7 plus 9 is 2. If I make the 9 negative, 7 minus 9 is negative 2. We need it to be a positive 2. Does that make sense? So this is the factors that I'm going to use. But since A is 1, the factors that you use, P minus 7, are the factors that you choose. P, it's really factors choose, use, whatever. P plus 9. Sorry. And that's it. Those are the best kind, right? You don't have to do any grouping or anything. It just is what it is. Tell me about example B. What is my leading coefficient in B? What is A? In example B, you're going to the right. Go down. Sorry. It's 1. So here's another one of the factors that you choose are the factors that you use. What's the product that I'm looking for here? A times C is 8. A times C. This is A, this is C, right? So 1 times 8 is 8, has to add up to B. 6. So yeah, 2 times 4. That becomes X plus 2 times X plus 4. Good job, Dylan. So when A is 1, it's sweet, right? It works out super easy, super quick. But when A is not 1, we have to use the grouping method or the box method. And I'll do the ones on the right with the box method because I know some of you guys like that method. Okay. So A is not 1. What am I looking for in the product? What is A times C? 100. So product of 100 adds up to B. What's the sum? Negative 20. Okay. Let's see. 2 and 50, 4 and 25, 5 and 20, 10 and 10. Which ones of those are going to work, Jack? Jack, are you with me? Which ones of those will give me a product of 100 but a sum of negative 20? Help them out, Charlie. The 10 and the 10, what do I need to do to the 10 and the 10? Yeah, if I make both of these negative 10 and negative 10 add up to a negative 20. And negative 10 times negative 10 gives me a positive 100. So that's what I'm going to use. 4x squared minus 10x minus 10x plus 25. All right. Quali, what's the greatest common factor in that first term? 2x. Rustin, what's the greatest common factor in the second term? You can't see it from there. It's negative 10x plus 25. Negative 10x plus 25. Nope. What are both of those divisible by? A 5. We're going to take out a negative 5. We're going to take out a negative 5. So let's do that. When I divide that first term by 2x, 4x squared divided by 2x is 2x. Negative 10x divided by 2x is negative 5. Yeah. I'm taking out a negative 5. Negative 10x divided by negative 5x is positive 2x. Positive 25 divided by negative 5 is, your repeated term comes first. What is that? What's your leftover pieces? 2x minus 5. Is there a better way to write that? How? 2x minus 5, the quantity squared. Yeah. Those are called special cases, right? That's the square of a binomial. The square of a binomial. All right, I'm going to go back up to D. Chandler, we're on page, I know they're not numbered, but if you counted them, it's page 5. Okay, so remember the first rule of factoring. So here's a little note, I would say. If A does not equal 1, the first thing I would do is look for a GCF. That's the first thing I would do. If A doesn't equal 1, look for a GCF and see if you can make A equal 1, right? So is there a greatest common factor, something that I can divide every single one of these terms by? Say it again. Yeah, 4. Dakota, I haven't seen you pick your pencil up at all. Dakota, pick your head up. It's not nap time. So we're going to take a 4 out. 4 times x squared minus 4x plus 3. So now, what is the value of A? It's 1. So now I can set up my times plus chart, and the factors that I choose are the factors that I use. So if A is 1, A times C, 1 times 3 is 3, has to add up to B, which is, okay, so let's list all the factors of 3. So what do we know? They've got to be what? They've got to be negative, yeah. So 4 times, because we can't forget that 4, x minus 3 times x minus 1. We don't have to factor it by grouping because the factors, because A is 1, remember that the factors that you choose are the ones that you use for your factor box. So that's what that becomes. Let's look at example E. See if there's a GCF. Do we have a GCF in E? Nope, there's not. What's my product going to be? What is A times C? Say again. I didn't hear what you said, honey. 28. Yeah, it's 28. What are we trying to add up to? What's the value of B? 29. Well, what two numbers can I multiply together to get 28 that when I add them, I get 29? 1 and 28, right? Okay, so those are my factors. We got to break it up to 4 groups or 4 factors. 7x squared plus 28x plus 1x plus 4. So now I can group them. I think I said I was going to do this with a factor box, though, didn't I? How many of you guys like box method, the factor box? Okay, let's do a factor box. So unlike multiplying a polynomial, we put these terms that we just discovered into our factor box. Oops, 28x, 1x, and 4. And you do, instead of like having the numbers on the outside and you fill in the inside, you're looking for a GCF, right? So what's the GCF in this row? Well, looks like I can take out a 7x, right? What's the GCF here? Just 1, because there's no x on that last term, Quali. What about the GCF here? 7x squared and 1x. The only thing that they have in common is just x, right? What's the GCF here between 28x and 4? 4. Notice that both these terms are positive. That means both of these are positive. So this becomes 7x plus 1 and x plus 4. That's using your factor box. Kind of remember that, kind of don't. Kind of don't, okay. Who remembers using the factor box? Okay. I'll do the next one both ways. One with a factor box. Well, actually, I'm not going to this one. I'll do G with neither one of those need to be done with it, but that's all right. I'll try G with a factor box, see if that works. Tell me what the value of A is here. A equals 1. So that means that the factors that I choose are the what? Okay, so what am I looking for on the product? What is A times C? Negative 56. What am I looking for on the sum? What is B? Okay, let's see. 56. That's 4 and 14, 2 and 28, 8 and 7. Which one needs to be negative? Yeah, if the 8 is negative, then I get a sum of -1. Since A is 1, my factors are going to be just plugged in there, right? P minus 8 times the quantity of P plus 7. All right. I'm going to drop down to G. G is another one of those special, a special product or a special binomial. Do we see a GCF in here? A 4. Yeah, we have a GCF of 4. So I'm going to take a 4 out of everything. And when I do that, I get x squared plus 2x plus 1. So on the product side, A times C, I'm looking for 1 that adds up to 2. What are the factors of 1? Yeah, just 1 and 1. So this becomes x plus 1 times x plus 1 with my 4 outside of it. But what's a better way to write that? Yeah, 4 times the quantity of x plus 1, the quantity squared. So I don't feel like we do a whole lot of practice with factoring, so we're going to do that today. We're going to practice factoring. We've got more to do on the back. We're not done with our notes. What you're going to do is you're going to take your factoring, and then end up using the zero product property and solving it. So that's where we are now. If the product of two factors is 0, then at least one of those has to be 0. So if you flip over to the next page, we are now solving the quadratic. We've been factoring it. This is factoring. There's no equal sign. Factoring, no equal sign. Now we are going to solve the quadratic. So now we have an equal sign. Still works the same way. This is still A, and this is still C. So we still have to do a times plus chart. So 1 times 12 is 12, adds up to a -7. So let's think of factors of 12 that add up to -7. Well, what about -6 and -2? Does that add up to say -7? I heard someone say it, -3 and -4. So since my leading coefficient is 1, since a is 1, what are the factors of this going to be? A is 1. So when a is 1, the factors that you choose are the factors that you use. So what am I writing? What is this factor? It's -3. So I write x, x -3, x -3. What's my other factor? But now these all equal 0. So that means that either x -3 equals 0. This was your zero product property practice last night, or x -4 equals 0. Well, if x -3 equals 0, I just add 3 to both sides, and I find out that my solution is x equals 3. Or I could add 4 to both sides and find out that my solution is x equals 4. Okay. Let's go to example B. Let's go to example B. So is example B set equal to 0? God bless you. No. How do I do that? I have to move. Oh, go ahead. I have to move these two terms on the right over to the left. How am I going to do that? I'm going to subtract them. I'm going to subtract the 5v and the 14. When I do that, I get v squared minus 5v minus 14 equals 0. Someone in here yesterday said, can't we just move it? It's confusing for me when I subtract it. I think it was you. Just move them. Remember I said, if you can move it in your brain, move them, right? So now let's look at our times plus chart. What's the product that I'm looking for? Well, A times C is -14, adds up to B, -5. So let's start listing factors of 14. Well, 1 and 14, 2 and 7. So which one of those has to be negative, Quali? The 7 has to be negative. +2, -7. So those are the two factors that I'm going to use, right? So what does this become? Like when I factor this trinomial out, what do I get? That's right, you got it. And what else? Yeah. And they both equal 0. So that means that either v plus 2 equals 0 or v minus 2 equals 0. So now what? Yeah, I could subtract 2 from both sides. So v is -2 or add 7. So v is +7. What about example C? What's going on with example C? Is it set equal to 0? It's not. Notice that my leading coefficient right here on my x squared term is negative, so I want to move it to I want to move that over. So I'm going to move both of these over. How do I do that? I'm going to add them. So that gives me a squared plus 3a plus 5a plus 15. Is it set up in a way that I can group them now? It is. Yeah, let's just factor them by grouping. Why not? Okay. Greatest common factor here. A. Greatest common factor in the second term. 5. So when I take an a out of the first term, I'm left with a plus 3. When I take out that +5 from the second term, I'm also left with a plus 3. 5a divided by 5 is a. 15 divided by 5 is 3. So my repeated term, a plus 3 times what I have left over, a plus 5, equals 0. So now what? It equals 0. So a plus 3 equals 0. Take away the 3. which means a equals what? -3. Or a plus 5 equals 0, which means what? Okay. We still have D, E, and F. We're going to do 2 of them. Pick which 2 do you want to do? Do you want to do D, E, E, F, or D, F? D and E, I agree. Let's look at D. What do I have to do with these 2 terms right here? Just going to keep drawing arrows, right? I need to move them over. And when I move them over, I'm just going to leave them as 4 terms. I'm not even going to combine like terms. 15a squared minus 3a. When I take this -7 and I add it to the other side, it becomes a positive 7a. When I take this positive 3 and move it to the other side, it is now a -3. Does everybody see what I'm doing? Do I have to show that step maybe? Do you need to see it? Okay, factor by grouping. What's the greatest common factor in this first term? 3a. I can take out a 3a, right? What about here? There isn't anything except a 1. There isn't anything except a 1. So when I take out a 1, let's see. 15a squared divided by 3a is 5a. And -3a divided by 3a is -1. Plus 1 is 7a minus 3. Do I have a repeated term? No. What does that tell me? Any ideas? Not really. Oh, no, there's a solution. That it just means you have to combine them. You have to combine them and fill out your times plus chart. Combine like terms. -3 and +7 is +4. So here's, I know it stinks, but I mean, rarely, but sometimes you have to do that. So times plus chart. What am I looking for on the time side? What is A times C? What's 15 times -3? It's -45. I gave you guys times tables. What does it have to add up to? To B. B is 4. So let's think of numbers that we can multiply together to get 45 that add up to 4. So what about 9 and 5? Okay, which one of them has to be negative? Because one of them has to be negative to give me a -45. If 9 is negative, then this is going to be a -4. So the 5 is negative. 15a plus 15a squared plus 9a minus 5a minus 3 equals 0. GCF here, 3a. GCF here, -1. So now 15a squared divided by 3a is 5a. And 9a divided by 3a is +3. When I take out my -1, -5 divided by -1 is a +5. -3 divided by -1 is a +3. Do I have a copycat now? Yes. So my factors are 5a plus 3 and 3a minus 1. Remember, these have to equal 0. So that means that 5a plus 3 equals 0 or 3a minus 1 equals 0. So let's start with the 5a plus 3. What am I going to do to both sides? Subtract 3. So that says 5a equals -3. Divide by what? Divide by 5. So a equals -3/5. That's my first solution. Or I could add 1 to both sides. 3a equals 1. Divide by 3. A equals 1/3. Those are my 2 solutions. Mrs. Bischoff. Yes, ma'am. Thank you. Dakota downstairs to the front office for Mrs. Harrell. Okay, we're going to do E. Is there a GCF in here once we move everything over? You think? I think so. Let's set this equal to 0. What am I going to do? Subtract 2. 2x squared plus 4x. Negative 28 and negative 2 give me a negative. Does anyone see a GCF? 2. These are all even. Divide by 2. When you take a 2 out, you have x squared plus 2x minus 15 equals 0. Times plus chart. Remember, the factors that we choose are the factors that we use when A is 1. So let's see. What is my product that I'm looking for? A times C is negative 15. What is the sum I'm looking for? 2. I know 5 times 3 is 15. One of those needs to be negative to give me a negative 15. Which one's going to be negative so I can have a sum of 2? There you go. So 2 times x plus 5 times x minus 3. So we don't say that 2 equals 0. You just, once that happens, you just drop that GCF. It's just gone. You either have x plus 5 equals 0, because you're just solving for x, or x minus 3 equals 0. So what's the values of x? Negative 5 and positive 3, yeah. So I'm going to drop down to this note at the bottom that says, what is different about the original problem and your final answer when the instructions say factor compared to when the instructions say solve? What is different? So when they say factor, I get something that looks like this, right? Like x plus 2, x minus 7. That's what it says. Like, this is what you get when you see factor. You get the product of two binomials. When it says solve, it's got to be set equal to 0. And you get something like this. X equals negative 2 and x equals 7. Right? Those are your solutions. Okay, so I'm going to stop right here. I'll fill those out in the video, but I'm going to give you guys an activity. So everyone has something different. So I want you to just come up here and grab a colored sheet and a marker. Sheet, marker, and an eraser. The small markers are going to be the best, but I don't know how good they are. I don't think I have enough erasers for everybody, but yeah. I'm just going to let you guys grab a colored sheet, grab a marker and eraser. I'm going to give you 5 minutes to fill out your sheet. 5 minutes to fill out your sheet. It's set up as a product. In sum, you're filling out the two factors on the sides. It's set up as a product and a sum. You're filling out the two factors on the sides. Not yet.